back to that last question from 3.1 at the end of the class. So to start things off, we're going to review on solving quadratics. So this is basically straight up Unit 2. So for all 4 of these, especially just like solve these quadratics, you can use any method you prefer. I'm going to prefer certain strategies depending on which question you want. So for this first question, what strategy do you think I would use to solve it? You could use quadratic formula. I would factor it, and my reasoning for factoring is, one, factoring's fast. I'm good at factoring, right? It usually gives me an accurate answer. It's pretty rare that I screw up my factoring and get a wrong answer. And basically, it's just a simple numbers. When I see numbers like 6, 1, and 1, those are pretty easy. So that's what makes me lean towards at least trying factoring first. Okay, that's my reason. And if I can't factor, then you're right, I would probably move on to the quadratic form. See, this one factors out pretty nicely. So when you factor that, you should get x plus 3, x minus 2 equals 0. And again, even though I encouraged a lot of factoring all 3 to 2, on the test, a lot of people went away from factoring. Right? And you were trying box methods, and you're trying quadratic formulas. Some of you guys did really good with that stuff, and some of you just constantly make little mistakes and not even realize it. Factoring is still what you guys usually find the most success with. So if you can factor to solve, I would factor to solve. Once I factor it, it means that x equals negative 3 would make x equals 0, positive 2 would make x equals 0. The second question asks me to solve this. This is a binomial, so it's a little bit scarier. But again, the numbers are easy, right? I have a negative 9, 1 right there. So before I jump into quadratic formula, I would see if I can't factor. What's the first step of factoring I should always try to do? I should always try to take out a greatest common factor. In this case, that's the only kind of factoring I can do or need to do, because it leaves me with a binomial that's a nice simple one, right? It's a linear binomial, x minus 9. And it leaves me with an x out front. My solutions to that question would be x equals 0 from the first one, and x equals negative 9, or positive 1 from inside the bracket. You see how much faster factoring is than quadratic. Quadratic formula is nice because it always works, right? But it's always going to take me like 5 minutes to do. Factoring is nice because it's going to work in some situations, but when it works, it's quick. That should be, if I gave this on a test, on that unit test, I'm budgeting 2 minutes for that question. So if you do a whole quadratic formula, that's how you run into those 5-10 minute problems on a question that should have been done in 2 minutes. 2 minutes would be generous. So that's just still my advice, because we're going to learn another way to solve these today. So it's still my advice to factor when you can. When you come down to this one, if we try to factor, I could understand if you didn't want to factor that. I could completely understand. Because the numbers are crackers, right? A 5, a 7, and a negative 6. Those are kind of hard. Most people don't do box method, they just go quad formula. That's fine with me. If you want to do box method, I won't do an example of it today. But of course, you can still use box method to solve things. I would dive into this. Even with those scary numbers, I would start off with trying to dive into it. I'm looking for things that multiply by negative 30 and that could be 7, 10, and negative. When we factor, if there's an a value, that a value has to show up in my binomials. So I put it into both. And then I have to divide one of them by 5. Making my factored form is x plus 2, 5x minus 3 equals 0. The actual solution is the things that would make those equal 0. So the first binomial, to make that first one 0, would be x equals negative 2. The second one would be 3 over 5.
Just make a round. But if like
If you didn't take a 5 out, it still works. In this case, it still works. It should work in all the cases, actually. Your factoring is technically just it's incorrect, but you screwed up by the same amount on both, so it actually should still work when you're solving. The way that my math teacher actually initially taught us was, you know how we say, like, put a 5 into both and then figure out which one can be divided by 5? He wouldn't worry about which one divides by 5. He'd be like, just divide the first one by 5. Because it'll still work out. It's just half the time you get the right one that works nicely, and half the time you get one that leaves you in really bad fractions. So, I don't know. You're right, it still gives you the right answer. It's just incorrect factor. The fourth one. Now, I'm 90% sure I can factor that thing because I've done this a whole bunch of times. But if I got that question, I would not try to factor it. What would I probably do instead? Box method or quad formula. One or the other, right? Like, I'm not putting myself through the pain of trying to factor that thing. You probably can, like I said, but in reality, I would use the quad formula. That's x equals negative b plus or minus root b squared minus 4ac multiplied by 2a. So as I put that into my formula, that means my answers will be positive 28 plus or minus 28 squared. I know it's negative 28. Minus 4 a c all divided by 2 times a, which that's what I would hammer out to try to do that. Just because I know it's going to take me a little bit of time, but it'll probably be the same amount of time as factoring anyway, because the factoring is hard. And I don't even know if I can factor it out. So I don't want to waste my time trying to factor if I can't end up factoring. The discriminant 0? Awesome. So when I go to calculate that, I get x equals 28 plus or minus root 0 over 8. What is the square root of 0? 0. If I add or subtract 0, does it make a difference to my numerator? No. My answer is going to be 28 over 8. Realistically, we would change that into an easier fraction, a simpler fraction, which would be 14 over 4. Oh, 7 over 2 would be easier. And then we would change it to a decimal 3.5. Just because it is a nice exact decimal, meaning that it terminates. If you have a terminating decimal, that's typically how you find it. You don't see decimals if it's like 0.111111, right? That's when they leave it as a fraction. That's basically a review of Unit 2. Right? Different kinds of questions, but all just solving. Something else we learned in Unit 2. This slide is exactly from Unit 2. We learned that there's something called the discriminant, and you guys are by far the best group that I've ever had at knowing what the discriminant is. So the discriminant is this thing underneath the root sign. It does not include the root sign. It's just b squared minus 4ac. You guys have identified it better than anybody else. The things we learned about it. We learned that if the discriminant ends up being a negative number, less than 0, that means that there's going to end up being no solution. Because if you were to actually calculate and try to square root a negative number, it doesn't work. Like the question we just had, you guys learned that if the discriminant equals 0, you're going to end up with exactly one solution. And lastly, if the discriminant is greater than 0, you're going to end up with 2 solutions. The reason being is that plus-minus symbol, right? So if you had a positive discriminant, you would have the addition situation for one answer, and then you'd have the subtraction situation for your second. Everybody remembers their discriminant fun? Oh, you say yes, you remember? Oh. I was not ready for the question. All right. Pictures. We also saw something like this. And so we talked about in Unit 2, when we were solving, what were we actually solving for? we're solving for x-intercepts, right? So that means that we have situations, and there's a lot of situations. We saw graphs yesterday that are flipped upside down, they're moved around, right? They can be all over the place. But there's only 3 types of situations that you're ever going to run into when it comes to your x-intercepts. You're going to end up with situation 1, which looks like this. I'll try to match the color. This is situation 1. How many solutions are there to that question? Why 0? You're right. There's no x-intercepts. The graph never crossed it. So by looking at a graph now and seeing that there's no x-intercepts, you know that there's no solution. That also tells you something else. What's it tell you about the discriminant? It tells you that the discriminant has to be less than 0. So just looking at a picture, you already know the discriminant must be negative. You can now link these 2 ideas together. Some of you were already doing that anyway, just by understanding that, okay, the discriminant is showing me solutions which are actually x-intercepts. So they're a little crazy. Don't you guys wish you were in English or social? Or social? Okay. This second situation, how many solutions would there be to that second graph? If it looks like this, sometimes it's hard to tell. It's always medium. Okay, so if you ever see a graph that's really close, like, pretty sure it's touching the x-intercept, but I'm pretty sure it's only once, maybe it's twice. Like, if it's given to you in a picture form, it's always one. If it's actually a graph you're calculating, then you have to be able to adjust your window to see for sure. But on a picture, we can't zoom in, right? So if you ever see a picture, always just assume it's actually. Let's say it's one solution. If it's one solution, what does that tell us? The discriminant must equal 0. There's one solution, one x-intercept, one real root. The last one's probably getting pretty obvious now. How many solutions are there to the last one? 2, there's one there, there's one there. I need a smiley face sometimes. So if you have 2 solutions, how many, or sorry, what would your discriminant value be? Greater than 0.
If it doesn't touch the x-intercept at all, like for once, but it does touch the y, it's going to be like something related. Like, what is it called? Like it's one solution, is that like?
The y-intercept is never discussed other than like a c value. So when you talk about solutions, it's only x-intercepts. So y-intercepts don't count as any sort of solution. That is a good question, because as we get into graphs, we will calculate y-intercepts, and we'll calculate vertexes, and we're going to calculate a lot of things. So it's important to just keep everything straight, right, in a nice, like, orderly fashion. Solutions are always x-intercepts, always. So if they ask you for what's the zeros, the roots, or the solutions, they're still talking about x-intercepts, no matter what. Everything else will be described more exactly. All right. Solving these things. What I want you to try to do is fill out this blank and this blank first. I'll do the first one with you to show you how I want you to do it. Okay? We're going to take a question and we're going to graph it. So I'm going to take x squared plus x minus 2, and I'm going to try graphing that thing. I'm going to graph it in my standard window. Sorry, minus 6. X squared plus x minus 6. Graphing on my standard window. When I graph it, just so you know you have the right graph, I'll make it pretty good. You could have something like that little red graph there. That's not the best example, but actually it's pretty close. want you to figure out the x-intercepts by graphing this thing, just like we did yesterday. So don't do any math. You're just using your calculator to find out the value of those two x-intercepts. Okay? To remember how to do that, we go second trace. The value in here is called 0. It's not working. Oh, okay, that's different. I'm like, not working at all. You go second trace and 0. So second trace, also having issues here. That's it, folks. I'm just going to pause that. The board, when it says to go left bound, that means I'm going somewhere up here because that's left of my x-intercept. And I'm finding this first one that I just labeled in green. So I go all the way left of it. I move my cursor using my left arrow up here into this region, and I hit enter. It says right bound, so now I move it somewhere down here, which is technically to the right of my x-intercept. I hit enter. It gives me an x-intercept of -3 and 0. I then have to do it all over again to find the second x-intercept, which is right there. So again, if you're following along with me, you're going second trace, which is right here. Second trace. You want the second option, which says 0. You go left bound, you find down here your cursor in blue, you hit enter. You then go above the x-intercept to the right of it, into this area. You hit enter again, and it should tell you that your second x-intercept is at 2, 0. Yeah. The next box. It says, yeah. Oh, I don't actually want to calculate it. So, looking at the graph, what do I know about the discriminant? It has to be greater than 0 because it has 2. Jackson actually calculated it. What's it equal? So it is greater than 0. But looking at this graph, I instinctively knew 2 x-intercepts means my discriminant had to be bigger than 0. It had to be. And it turns out that it is, which is wonderful. Alright, factor form, I think looks like this. And if I was to solve the factored form of this thing, -3 and +2 would be my answers. Those are my x-intercepts that I just calculated with my calculator. And that means you now have another way to calculate answers when you have quadratics. That other way is graphing and looking for x-intercepts. Some people are like, man, I wish I could redo that Unit 2 test. So you could probably just match it all up, right? Yeah. On the reassessment, feel free. On the original test, if you still haven't done it, which somebody hasn't, you could also do that. But remember how the test is formatted? It's usually like, solve with box method, or it's root A plus B is the answer. What's the value of A? Like, you can't figure out those things using the calculator. So even though it might feel like, oh, I could have figured it out, it actually would be no help in that test. Because it's designed to force you to know how to do things. Yeah. Exactly. No, it means the y-intercept would be 0. So it would be right at 0, 0. Hey,
Are we able to come in at some point next week and look at a unit test?
definitely. You come in at any lunch or anything like that, you come do that. Or after school or before school. Okay. That's the y-intercept that you're talking about. Yeah, he was saying because the c value is 0, what does that mean? That is also going to be an x-intercept for us as well. But we'll talk about that in a second. Yeah. Yeah, sure. Okay. You can solve this thing by graphing it. That's the point of this. So graph it. See if you can solve it graphically. Find the x-intercepts using your graphing calculator. So give it a shot. I want you to try all 3 of these. Using your calculator, figure out the x-intercepts and the discriminant. Don't worry about factored form. I'm not stressing about that right now. I just want you getting answers for the x-intercepts and the discriminant using your calculator. So practice with your calculator. Yeah. So hopefully you figured all those out. Each one using your graphic calculator. The biggest thing is probably the second one. People look at this, and for some reason the 0,0 throws them off. It's still an x-intercept. It's your x-intercept and it's your y-intercept. Right? So it's the same thing, but it still counts as an x-intercept, so it still counts as a solution. When x equals 0, y equals 0, so it's still a solution. So that means the discriminant of that thing would be still greater than 0. The factored form for these questions. You already did the factored form for a couple of them. These are the same questions as the first slide. So it's x, and then x minus 9. This one ended up being x plus 2, and then 3x, no, 5x. So 5x divided by 3, 3x. No, 5x. The last one we had factored, yeah?
If the second integral x plus 0, and then x minus 9, that's the same thing.
Same thing. What's any number minus 0 going to be still? Any
That
number.
doesn't show if it would count as right.
And you should be able to see that, like, when you have these solutions, they should plug right into your factored form. And you should see something similar, like the negative 3 and the positive 3, the negative 2 and the positive 2. You should see that they're linking together. This last one's tricky. The only way you could get the factored form out of it is if you tried box method. The diamond works, it's just going to be a tricky diamond to get. Did anybody try it? Yeah, we did, but we never factored it. Did anybody try factoring it? You should have got, because you ended up with minus 7, 2, yeah, like that. And it would be squared. There would be 2 of them. So if you had done that in your, what do you call it, your diamond method, you should have ended up with negative 14 and negative 14 on the sides of your diamond. And then you should have plugged those in. I don't think many people diamond method that, but that's what it should be. Some of you guys put this, right? And you kind of like, you were figuring out that it must fit in there somehow. And that's okay, that's fine too. The big thing is that you can solve quadratics by graphing. That's a new tool for you to use, and it's a tool you're going to have to use in this unit. You could also still do it by factoring, and you can bounce around forms if you want. Your factored form that you learned in grade 10 looks like this. And we'll see different letters. It doesn't have to be A and B. A lot of the times it's M and N. You might also see X1, X2. We'll talk more about factored form in the future, but you should be seeing that there's a correlation between factored form and solutions. We will talk more about that in a future lesson.
Do we still use like slope form and all those other forms we're going to break down in this unit?
Yeah, you're going to need those. Yeah. Especially when we get to unit 4. Yeah.
How about you ever use X coordinates?
They call it this. x-intercept, second x-intercept. There's two I's. Yeah, that's the other formula I see it in, or you might see M and N. A little one. Yeah, no. Like usually they use I's, like Roman numerals. But we'll get more into factored form in the future. Awesome. There's two questions here. I want you to try to fill out the entire chart. This involves stuff from yesterday. Okay? So I'll give you an opportunity to fill it out on your own. Try not to share answers. Okay, so try it on your own. See how much you can remember. We will go over them together. Okay, so I'll explain where I'm getting answers from. For the most part, I'll get answers from graphing it and using my calculator. But I want you to try and see how much you remember from yesterday. Slash a little bit that we've done today. Not too bad. Okay, both of them are in factored form. I use diamond method. Okay, so nice and simple. Vertex form. The only way that you can get vertex form, you're not going to do it algebraically at this point in your lives. All you're going to do is you're going to make your calculator, go second trace, choose minimum or maximum, left bound, right bound. Okay, that's the only way to get vertex at this point. You will learn a way to get vertex once we learn something called vertex form. Vertex form and getting into vertex form is harder than just calculating. So calculating is still going to be like the number one option if all I want is decimal values. To get into vertex form, we'll need the box method, which is why we learn the box method. Because it helps getting into vertex form. It helps to actually calculate vertexes. Vertices. Hey, the x-intercepts you could solve with just your calculator, or you could solve using factored form. X-intercepts always have y values of. So y value of all my x-intercepts? 0. So if I went back into my factored form and changed y to be 0, then you know the answers are going to be -3 and -1. That turns out to be my x-intercepts. So you can solve them algebraically, or you can solve them using your calculator. It's your choice.
Why do you have the domain up there?
Because it's still important to know, and it's going to change once word problems come. So it's not always going to be XCR. Y-intercepts. What's an easy way to find my y-intercepts? It's my C value. So y-intercepts are always just this number right here. The x value for a y-intercept is always 0. Those like trivial facts of x-intercepts always have y's of 0 and y-intercepts always have x's of 0. You just need to know that and be drawing from that. And that can be a really big holdup for people in this unit. That you need to know x-intercepts always have y's of 0 and y-intercepts always have x's of 0. The axis of symmetry was something new. The axis of symmetry was something that cut quadratics in half vertically. So that if you folded it over, it would be the exact same on both sides. You can always find it by looking at the x value of your vertex. So you'll notice that those two things are linked. The axis of symmetry and the x value of your vertex are the same. The domain for non-word problems. It is always XCR because it goes forever to the left and forever to the right. All I need you to do at this point is understand what a domain is. It's asking what x values are on that graph. Everything to the left, everything to the right. Once we get to word problems, you're going to have to be able to limit what your x values can be. For instance, if x represents time, you would no longer include negatives. You can't have negative time in that context, possibly. So that's when the domain will get harder.
Is it parabola that doesn't go like minimum max are the ones that go to the side?
Those are not parabolas. They do exist, but they're not parabolas.
Oh, I see.
So if it goes to the side, then we don't do it yet. Next year you do it though, no.
So the time travel count as negative time.
No.
That'd be really weird if we got a question something like that.
That would be good.
I think it would to go back. It'd be really good.
Yeah, but isn't it like kind of proven that time travel means that you're actually moving really fast forward in time? Like you move so fast that you go backwards in the light. Okay, that's